All right, go ahead.
Oh, no problem. So yeah, for the recording, we'll start with the Fortran project, and something that Sebastian proposed is about the Git workflow strategy recommendations. So Sebastian, can you elaborate on that, please?
I just noticed that Milan by accident changed his merge strategy on the Fortran lang repository, and we were observing squash on merge for the commits instead of merge commits, which therefore I want to raise the question: what do we want to do in general about this? So, is there do we want to recommend a general strategy to work with Git and with GitHub, and how do we process patches in general? I mean, I opened a discussion at the Stdlib repository regarding this and linked some development guidelines from other projects which are very explicit about how they want to see Git used and how they want to see branches built up and feature branches kept up to date. Maybe we want to set up our own guidelines on this as well.
I think guidelines would be good. I mean, we've had a few issues in the past due to lack of guidelines. There were contributors working on a branch on the Fortran lang Stdlib repository rather than their own fork. So we should ask people to fork the repo, work on their own local repository. Also to work in a feature branch rather than work in their main or master, whatever it is, that is their main branch. There was a recent issue of a student candidate working on one PR from their master, opening a PR, and then opening another PR for a different feature, but with commits, just keep adding commits on master, and then that duplicated some commits in the PRs. But feature branches would solve that. So I think we should have a recommendation. About the merge strategy, I don't have an opinion. I'm fine with either. I know there are people here that preferred one way or the other, and I see merits to both. Okay, squash and merge, you get one nice clean commit, but then you lose some information about which commits changed which file. So sometimes fine-grained information is more useful, and sometimes you just have a lot of noise, especially if a PR was so big and there are a lot of little edits from contributors, then it gets messy. So I don't know if anybody has a preference, I'd be happy to go with that, or maybe we can come up with some kind of rule. Hey, we'll use this one by default and the other one for special cases.
My recommendation on this is to leave it to the contributor, but leave it to the contributor to rebase the pull request at the very end. If so, for let's say my own workflow is, let's say I submit 4 patches, but then I get a lot of feedback and I have all kinds of fixes, and then I have to fix up CI typically and so on. So I end up with kind of 10 commits which are kind of ugly. So what I do after everything is reviewed, I rebase it and I create a nice commit at the very end. So so I'll have the 4 initial patches plus the extra commit at the very end that I nicely polish. And then that way there are 5 nice patches and everything's fine. Milan, can you mute the person talking? Thank you. Yeah, and then and so because sometimes, as you said, when you squash it, it's nice to have the commits kind of in a logical manner showing what files they change. But it's a good idea if you have like these 50 commit pull requests that each commit is just a simple change and then the next commit reverts it. It's a good idea to polish the history before merging. But I think the good policy is to leave it kind of on a pull request by pull request basis.
We're dealing with this with Mom6 as well at the moment, where in our group, we make very clean commits, but we get submissions with people with 200 plus commits. And yeah, we initially tried squash and merge, but we found, I mean, on one problem, it puts the squasher as a co-author on the commit, which is a little confusing sometimes. And another thing is, I think people just don't, sometimes they don't know what's going on, and then they don't understand why their commit is changed. So we're trying the cultural approach as well, where we say, please rebase, please clean this up. I don't know how far we're going to get with that, but I think we're kind of leaning away from squash and merge as well via GitHub.
I think I like the idea of definitely having as a requirement fork and feature branch, but anything other than that, I worry that some of the advanced features of Git end up very scary for newcomers sometimes, and I don't want to scare people away because they're like, "Oh, please rebase this," and then they go, that is a scary operation to me, and I don't want to bother with that."
So the way to do that, yeah, I agree. The recommendation should be, consider like, this should be the goal, but it should not be discouraging. In other words, we should encourage people to submit, even if it's 10 ugly patches. And in that case, we can squash it while merging if it's over their technical ability. But a lot of the contributors want to learn what the ideal approach is, and the ideal approach is to rebase.
Yeah.
That's one, but we don't, how to say it, we want to accept contributions from people who don't have the skill, and to do that is you just let them commit as much as they can, and then at the very end you squash it with the button, and that I think is the ideal approach.
Yeah, that's what we're doing as well. We're saying thank you very much, but please next time don't do this. Which means we get the contribution, but we hope they won't do it again. I mean, I think we're a little concerned long term, because this does contribute to bloat in the .git directory, and it does get big. And that's not just a cultural problem, that's a real problem.
Not if you squash it. So if you have a contributor who doesn't know
if
you squash it, you get a commit, and you tell them, if you want to, you can learn eventually how to rebase it. That way you can get more than just one commit.
Yeah, and if you do nothing, it does start to grow to the point where it starts to be a burden on the whole repository.
Yeah, let me just add what we've been doing on classic flying, and then recognize that the LLVM flying is much more strict because of partly because of the players involved on the NVIDIA side, and partly because of the LLVM community. But on classic flying, we require people to do their own rebase. Because it's the only way to guarantee that they think that what they think is really working is going to work against the current branch, or current main. And if we find that the commits are are really noisy during the review process, we'll ask them to squash the commits, because it's the right thing for them to do. And for the we have a little bit different community in that these are all virtually all professional compiler developers, and vendors. So they're willing to learn what they don't know in order to do the right thing. But my preference would be that if you have guidelines, you'd say, hey, strong preference for squashing the commits, unless it's unless it hides real work that's history that you want to maintain, and strong preference that you do your own damn rebase.
Okay, so I think that all of this should end up in the guidelines. Sebastian, did you already start something on that? I saw that you did quite a lot this last time on these guidelines and README. Thank you for that.
Thank you, Sebastian.
Did you?
I haven't wrote anything for Git guidelines yet. I have some material from other projects which I could base it on, but writing a complete Git guideline from scratch on my own is quite a task. So if anyone want to join on this effort, really appreciate some help here.
Yeah, sure. So you already opened a discussion there. It's already nice. We can probably follow discussion there.
Could be a good GSOC student batch requirement PR. Hint, hint.
Yeah, indeed.
I mean, it's a bit more difficult to do because it requires some knowledge of the project and prior knowledge of the organization itself to make it fit in. So besides just writing down what you think is the best, there's a lot of work that has to go into the presentation to make it work well for the wider community, from onboarding to also some contributors.
I agree that context-free guidelines are worse than no guidelines at all. And we do have the I think we've got documentation on the contribution process for the two flyings. I can make that. I can add that information or try to summarize it for y'all.
That'd be great. Thank you, Gary.
That would be nice. Thank you. On that, I propose to move on to the next thing, if I can get back my screen. Yeah, so the next point is about Stdlib. And Sebastian proposed to discuss about a bit related topic, which is to update the star guide or the workflow. Sebastian, I think that you opened also a pull request for that.
Yeah, and started writing down what I think are the guidelines for working with the CMake in Stdlib, from what I found from the CMake document itself and from the pull request adding those CMake guidelines and the issues discussing those. I guess this should be mostly correct, but I would really appreciate if somebody participated originally in writing those would have a look and maybe except for just stating the status quo in this style guidelines, we might also want to think about what should be our rules for the build system for both make and CMake. So right now,
we spend our time porting to FPM, and then way we don't have to write any guidelines.
No, I think this won't work because FPM is not yet able to generate CMake, and even if it is able to generate CMake, we will need those guidelines implemented in FPM. So we have to write them at some point. So we can't avoid it. And writing them down now would probably be more effective because then we have something we agree on, which we can also then implement and encode in FPM.
All right.
Any other comments on that? I think I read them and make some comments. Many typos and stuff like that. I think it's quite important to have them also. For me, they were quite okay. And, could be merged as is. I don't know, Sebastian, if you have questions for that. Or otherwise, could be nice if someone could read them also and agree or not on that for merging on it. Yeah, good. If there are no other comments, I propose to move to the next one. Let me find it back. It was also proposed by Sebastian, and it's quite an issue that is there since a long time. It's about the versioning. It could be nice if something could be decided today, or not to wait too long for that. So Stdlib is still not versioned, and yeah, what are the next steps basically to get Stdlib versioned and what should be done? I know that I think that FPM is versioned, so could be based on that, on this experience. Sebastian, do you have other things to mention for that?
I think we arrived so far that we want to start with a major version in 0 at some point, but we didn't agree on the guidelines on when to bump the minor version. So I think this is the only thing that is still missing to actually start putting a 0.1 version on Stdlib and continuing from there.
Damien, not too long ago, suggested to me that there are some projects where semantic versioning doesn't quite make sense because different pieces will change at different rates. And I think Stdlib might actually be one of those projects. So I dropped a link in the chat to calendar versioning. So I wonder if Stdlib might actually be more appropriate as a different versioning scheme than trying to stick to semantic versioning.
Yeah, I would say that in general, I think I'm moving towards calendar versioning. It's a lot simpler. It doesn't communicate as much, but there's also the question of, do you really want to overload the version number by trying to communicate too much, right? So, and the other question is with semantic versioning, the major version, my recollection is that you change it when it's a breaking change, like something that changes the interface, but that is more important for a library than an application. So there's a lot of cases where I think it doesn't really apply. I guess it depends on how you define interface. So yeah, I think I'm just honestly moving more towards calendar versioning for everything.
We also do a version of that as well. We do rolling releases. We've given up on numbers.
Yeah, yeah. I've kind of learned over time that when I run into problems, a lot of times I'm maybe just overloading a concept too much, you know? So, because then we end up having a lot of discussions about whether this qualifies as a breaking change or, I mean, yeah, it gets, we could save all the discussion if you just version it based on the timestamp.
So to that, as an application, I think I've seen a lot of applications, even around me, kind of moving towards the calendar versioning, whatever it's called. But for library, we are talking about Stdlib. That's a library. So it will be part of FPM. FPM has the version resolution so that you can, or will have. So we are modeling it by Cargo, and Cargo has the version resolution. If you use semantic versioning, Cargo itself kind of has understanding of that and can recommend you upgrades or not upgrades, you know, based on your specification. And I think it seems to me, if it's a library, it makes a lot of sense to use the semantic versioning for this very reason. And also be very careful about breaking stuff and kind of communicating that carefully in the version.
I just worry that with Stdlib having such a broad scope, you're going to bump the major version number so frequently, especially early on, that it almost becomes meaningless.
Well, not unless it's 0.
It's
We
zero.
can be forever in 0.
Well,
I suppose.
Yeah,
At some point, we'd like to get to 1.0, right?
Yeah, once we stop kind of adding so many features so quickly, then we should move to 1. But until then, I think we can kind of break things.
I mean, Linux tried this, and now the Linux version numbers are pretty meaningless.
Yeah.
So you kind of end up in that place, but maybe it's a long-term problem.
I have to admit, a huge part of my motivation is emotional, though, so it shouldn't necessarily sway other people. Just, you know, I feel like when you do something really big, and you know, it's nice to announce it with a big major version number. And if the major version number doesn't change for a really long time, it makes me feel like a project is static, you know. But that's purely just emotional. I don't know that it should necessarily be convincing to anyone.
I like it. It seems calendar versioning would be more appropriate for Stdlib, considering how many open and long-living PRs we have. And say for semantic versioning, if we decided to bump version on every feature, then it would be kind of, unless we had it fully automated, it'd be difficult to track and sort of agree on so this PR is going to be this bump and this is going to be, and then they can get reordered in time. So then you have to worry about that. One thing we maybe lose with calendar versioning is the concept of major version 0 versus 1, somewhat corresponding to experimental versus stable, although more recently, maybe late last year, we somewhat agreed on that we would have certain procedures in any modules to be experimental, to be allowed to be broken as they evolve, and some of them at some point entering the stable. So kind of like what Rust does. So with each Rust version bump, and I think they use a semantic versioning, they stabilize a number of standard library functions, and they stabilize some language features. So up to that point, a function or a feature could change and could break with an update. But once it's stable, it's stable. So in that model, we were kind of doing version tracking per function, which seems more complex, but it allows you to stabilize parts of the library at a different time, which it seems to me Stdlib requires that if we were to still follow that model where, hey, we want to implement future intrinsics from, say, Fortran 2020X, we want to implement them ahead of the standard so people can play with them. But then once they're in the standard, they get stabilized.
So basically the policy would be if something hasn't been declared stable, breaking backwards compatibility with that doesn't necessitate a major version bump.
That's right. I was going to just say that. I think we all agree we want the experimental versus stable or unstable, stable, whatever we call it. I think we all agree on that. And I think it can be incorporated with either versioning scheme. And I think the semantic versioning scheme, exactly as Brad said, would not apply to the unstable. So the unstable can change and you don't have to bump the major version. And I think with the semantic versioning, isn't it the case that you only bump the major version if you break compatibility? So if you're just adding features, you just do like 1.1, 1.2, 1.3, 1.156. So I think that works. Or we can, I think either is fine probably.
It seems reasonable. If you go to calendar versioning, at some point you are afraid if you want to move back to semantic versioning, because then you either have to start with whatever year you were in, as that's where you restart semantic versioning, or you're afraid at some point you'll duplicate version numbers because you'll get up to wherever you were in the calendar versioning. So I think that seemed reasonable for sticking with semantic versioning, with the rule that if something hasn't been marked as stable, you don't have to bump the major version number. Seems reasonable to me.
So right now we are at 0. So the immediate question is, do we have to decide right now for that, or can we just kind of keep going with 0, and then once we get closer to 1, we can revisit the discussion and see if we want to move to the calendar?
As far as I understand it, for semantic versioning, basically none of the rules apply if you haven't released version 1.0. It's basically you can do whatever you want. You're just saying like we're not ready for 1.0 yet, so don't expect anything to be stable yet.
Yeah, and we don't have to decide anything now or ever, but the sooner the better. And Andre, you mentioned maybe if there's an issue with calendar versioning with version dependency resolution, say in FPM. I don't see why that would be. Like, I think it would work just as well.
So in cargo, you can tell when you depend on a library, you tell it that you depend on library A version 1.4. And what it means is it can be 1.4 dot any minor patch, but it will not upgrade to 1.5. If you use the calendar versioning, how would that work?
Same.
I think as far as FPM is concerned, it would treat it as semantic versioning, which would be kind of okay.
So how would it? Well, so the calendar versioning will be version October 26. So how would it?
So it'd be 2021.10.1, and it would just go, well, it won't upgrade to November, and it won't upgrade to 2022.
But could you not end up in a situation where you have basically dependencies that there's no solution to the version constraint problem because the
Yes.
dependencies have different calendars and that you
Yeah.
can't overlap them in the semantic versioning framework?
You end up with that problem with semantic versioning anyway.
Right, yeah.
What about leap years?
Yeah, you end up with the semantic versioning, you end up, you can easily end up in a situation where it's impossible to resolve. So you have to then help them package manager manually.
Mhm.
So what do we know for now? Do we wait still a bit until we see a bit better what to do?
Technically, is there a way to keep releasing? I would like to start releasing the Stdlib. Is there a way to start releasing in some kind of a scheme we can agree upon and then kind of think about the pros and cons of the approaches?
I would vote for Andre's proposal that we stay with semantic versioning for now, with the caveat that we don't bump major version numbers if something hasn't been marked as stable. And since we're still in 0 point something, just keep going with where we are.
Fine with me.
Yeah, currently we are at 0.0, I think, or something like that. Should we move to 0.1?
That's what I was thinking, yeah. And then 0.1, 0.2, and so on.
And what does need to be done to move to 0.1? I have no idea. Do we keep everything still in the experimental space?
Yes, as I understand it, experimental versus stable is now independent complete of version. It's like a binary flag, and it's per procedure, per derived type. And we can just start being 0.1.0 right now.
I think so.
Should we now discuss maybe the harder question of releases, which is how do we release? Do we release sources, pre-processed? How do we pre-process? Do we pre-process with all 15 ranks or keep sources smaller? Do we do binary releases? How big are they gonna be?
So I would do it step by step. So I would start releasing the source code, and then later, as we kind of get the workflow going, automatic, hopefully, we'll add the binary later. The binary releases we can also tie with the FPM eventually, as part of the FPM. So then the only question and I think we already agreed to release 0.1. So the only question is, how do we do the source tarball? And the only question seems to, well, should we pre-process or not? I would strongly vote for including the pre-processed file so that when package distributions and end users just want to install from the tarball, they don't have to have any kind of Python, none of that. And then assuming so let's discuss that. And then after that, the next question is, should we pre-process with rank 9 or 15? That I don't know.
One option for source distribution may not be as popular is we could make a single source file distribution, kind of like I think SQLite, or however you pronounce that, does it. So you'd have one F90 file with all the modules concatenated. That makes it very easy for people to plug into their projects. Could be less relevant when it had it as an FPM package.
I think one problem you might end up with is the memory limitation when you're compiling it, if it's all in one source file. But
especially for the 15 ranks, I would suggest, it seems to me like in the long run, we want to have just one part of the release will be one tarball with all the source code. So I would start with that, have separate files. Maybe we can start rank 6 or something so that it's kind of useful in most cases. I very rarely have arrays longer than 6. I have sometimes, but very rarely. 6 is
I
kind
never
of,
have more than 5.
6 is common because you have, in 3D you have loops over, and then typically you might have twice those loops, but over 6 is very rare. And so can we do up to 6, or is that an issue with some compilers?
I think that it works up to 7 for most of all compilers that we test in GitHub.
So we can do up to 6 or 7 as long as it kind of works everywhere. And then once we start releasing, then later we can kind of experiment. Can we do up to 15? What are the issues and so forth?
Yes.
Sounds good.
Good. I think that yeah, with an agreement.
Maybe one thing on this.
Yeah, sure.
Did we agree on when to bump the minor version from 1 to 2? So what is the event which makes Stdlib version 0.2 and not 0.1 anymore? Do we do it on a new feature? So every time a new feature gets on master, do we do it on a specific date? So
we do it almost on every release. I would suggest, so essentially, let's say we release 0.1.0. Let's say we discover, oh, there is a tiny fix on Windows that we did not notice. Then we release 0.1.1 if it's just a minor fix. But if it's adding a new feature, then we bump it to 0.2. And so every time, how often do we want to release? I guess that's the question. And my suggestion would be to just kind of keep bumping it for every release.
That could probably be a CI action, right?
So how often do we want to release?
Well, I thought you just said on every merge into master.
Oh, wait. Oh, so you are thinking, well, what I had in mind is that the release will be that you tag it. You tag the Git, and that's a manual action, but you tag it when we are ready to release, whether every week or every month, or how do we want to do it?
I think you should plan in advance what features you want to have done for the next release. So say when these things are done, then we'll release the next version. So don't try and guess on the fly or.
Yeah, and essentially it's a manual action that you decide, okay, we are ready, and then you tag it. What I would do in addition to releasing these releases is to have a development version, which is the latest master that can be automated by the CI to create a tarball. I do it with Fortran, works great. That way people, as well as myself, can easily check the very latest development Git commit and test it out that everything works. And it's also helpful before actually making the release to make sure that manually everything actually works before you tag it. So that can be done on the CI automatically.
Okay, good. Thank you all for that. If there are no other comments, otherwise it could be on the GitHub. Propose that we move to the next topic, which is to discuss about the module for tolerant comparison that was proposed by Arjen. Is Arjen there? Oh, no.
No, Arjen's not on the call, but I'll share my screen and show it to you. So basically, this is a module that allows you tolerant comparison of floating point numbers, so that when you want to make a comparison and you want it to be true when the numbers are approximately the same, like what you think are the same numbers, but because of floating point representation, they're not the same internally. The intrinsic comparison operator will return false, and this would give you a true within a certain tolerance margin. I don't want to discuss an implementation. So this is a PR that went in, I believe just Arjen was inspired by some question or comment in an issue thread, but there wasn't a dedicated proposal for this. But basically, I just want to show you that it gives you, these prefixed by T custom operators for comparison. So they stand for tolerant comparison, and then there's probably in there some controls for what the tolerance is. Now, originally Arjen named this Stdlib tolerant. I thought it was a bit awkward name because tolerant on its own may not necessarily tell you what it is about. So I suggested Stdlib comparisons. To be more explicit, you could call it Stdlib tolerant comparisons, but that's kind of unwieldy, a bit long. So here I'd just like to get some feedback about the naming of this module. And in general, if this is something that would be useful and in scope for Stdlib, I think so, very much. But I'd also like to hear from others. So basically, what you think about how useful it is, and what do you think about the name?
It's something that I use to implement myself on occasion, but it's also, I think there's gotchas in here about trying to implement one that is supposed to be kind of universally applicable, because I think the tolerance there is almost always context specific. And so I think this is kind of the reason that I don't know of a language that has tolerant comparisons built into the language or in its standard library because of that reason. Floating point math, like the tolerance here is always context specific, and there's not a universal answer to this.
NumPy has it. I was going to suggest to explore other languages. NumPy has it. It's called close or close equal or something like that. Regarding the implementation, I also had to implement it all in a lot of my projects, and it gets very tricky because it depends if you want to have relative comparison or absolute or both, because each of them works kind of differently. So if you are around 0, you want to kind of probably have the relative because the absolute is going to be small anyway. But if you are far from 0, I can't remember. Like in one way you want the one, the other way you want the other one, and then depending on your application, sometimes if you are comparing both around 0 and far from 0, you kind of want to combine them, and it's very tricky to get right. But NumPy has it. NumPy, the NumPy library in Python. So we should look into. I don't remember right now what it's called, but we should look it up and explore exactly how they've done it. And I can also share. I think I asked this very question either in NumPy list or Stack Overflow like 10 years ago. I'll look up the discussion there. It's that there's a lot of non-trivial stuff, but I think it's definitely in scope, and I would love to have this in Stdlib, well documented and kind of with examples like when you use it and how you use it, and regarding the tolerant you specified as an argument. So I think those functions should be very usable.
Okay.
In the proposed interface, how do you specify the tolerance if you're using the argument, the operators? Sorry.
It's not clear to me that you can, but let's see. So let's see what's public here. So we have a tolerant floor, ceiling, and round, and we have operators. So there's various epsilons here, but those are private. So it seems to me currently you can't configure it.
So
to
we'll
give it a tolerance, and with binary operators, you couldn't do that. So it will probably need to be a function that allows a third argument being the tolerance.
So I've got several comments. First of all, I'm very tolerant of long names, so I wouldn't have any problem with calling it tolerant comparisons. Stdlib calls it tolerant comparisons. Okay. But I also think the shorter names are fine too. It's the sort of thing that sounds at first like it'll be really useful, but as others are noting, I think it could be really hard to get it right in a way that's broadly useful. If I were going to do something like this, I would probably introduce object-oriented programming. If I'm comparing two things, do I really just care about the difference, or is one of them actually the reference, like the thing that matters the most? In which case, I'm probably going to compare a lot of things to it, different estimates or something, in which case, if I had an object, I could just store the tolerance inside the reference, because that's where I really want it, right? And so then you could recover the operator notation by making a decision to either go with the tolerance that's in the reference, because that's probably the one that matters, or to go, or if you don't establish a reference, to go with the tolerance that's the tightest, I guess. But it seems like a good, I too have the question of like, if you're using the operator notation, which I love operator notation, then how do you incorporate the tolerance. I think you'd have to have objects, basically.
Yeah,
But-
I quite like that idea actually of storing the tolerance with the object, because obviously it's quite common for different kind of variables to have different tolerances associated with them. And you may actually be able to build in something like uncertainty propagation into that as well. So I think that's quite a nice idea.
For operators with custom tolerance, there could be like a module global setting that you could access. You could set it. Operators would have access to it. That's not as clean because it's in the global scope.
One thing I've also noticed in practice in places where you like, okay, I know that these things aren't actually equal, but I kind of want them to be tolerant equal. That tolerance starts to drift. Like, yeah, well, this time I know it wasn't outside the tolerance, but I really expected it to be equal. So I'm going to shift my tolerance again. And like, when you get into, actual applications where you're using these, that tolerance starts to drift because you're like, yeah, but that one was so close. You should have actually, so I'll adjust my tolerance again. And it changes all the time.
Yeah,
Basically,
it's an argument that you change all the time.
as the project wears on, the standard for success slips lower and lower.
One thing I'll say also is that in the case that I've encountered the most recently or frequently, I want to compare two lists of numbers, like two 1D arrays. And so we've been using this on projects a lot where we get handed a legacy code that has no test suite. And the very first thing we'll do is take all the output, because we figure if you printed this out, you probably care about the number. So we'll take all the output and package it up into an object. And then we want to compare, when we do new runs, we want to compare the new results to the reference object. So in that context, the tolerance gets applied to a norm of a vector, basically. So it would be really useful to have vector operations in here, like 1D array operations in here too. Somehow.
Yeah, great idea. I usually use maxval. I do the absolute value cell by cell in a vector, and then I do the maximum value of the largest error. And
yeah, that's exactly what I do. And to be fancy, I call it the L infinity norm.
That's right.
Okay, thank you all. I'm sure Aryan will appreciate feedback. Okay, FPM. I would like to discuss basically what ended up being called plugins. It may not necessarily be the design for FPM plugins, but it started with this this discussion from John Urban. He couldn't make the call today, so I'm just going to present this, but mostly his work. But basically, in a nutshell, the idea is to allow you having a third-party application that will be called in a specific way, in which FPM would then recognize and then assume it as a subcommand. So to be specific, you could make something called FPM search, make an FPM package with it, build it. So the executable is called like that. Now from FPM, if you didn't have this executable around, then you type FPM space search. Actually, let me just take you to my thing. So I have from this discussion. So I forget their name, but the user Broccolis, they had this AVP PKG tool, which basically just parses the JSON file from FPM registry, and that does like a search of packages. I managed to convince them to call it FPM search, so then it could work with John's pull request. So if you go to this repo, basically it shows you how to install. What's cool about this is that this repo uses Stdlib as a dependency as well. So it takes a little bit to build, but once you do it, you have something like this. So it downloads the registry, and then it lists. So FPM search without arguments just gives you a list of packages, but you can give it a pattern. Say I want to list all John's packages, and I know that he calls them all with uppercase M underscore. Then you get all of his packages here. Now, if I want to do something specific more about, say, M color, it just lists that and it tells you what it is. You can do a verbose. And this basically gives you the manifest entries. And if you do toml, it gives you exactly the toml entry that you need to put in your fpm toml file to use this as a dependency. So it's pretty cool. It's kind of a convenience tool for fpm. Now back to this third-party tool as a plugin idea. So my fpm is, just to show you, so this is my local install. It's should be 0.14. If I do fpm search, of course it will say it's an unknown subcommand because there's no subcommand called search for fpm. Now I have also built the fpm from John's PR, which implements this, and that's right here. So now if I do fpm search, what it does is it basically just searches for fpm-search executable, and if it finds it, it uses that as a subcommand. So basically what I was hoping to get is some feedback on what you think about this approach to enabling very easy third-party integration into fpm. So it makes it very easy for a developer to make some tool easily call from fpm as a subcommand, mainly for development, prototyping, testing, before you actually propose it as an idea for integration as a full subcommand into fpm.
First, the search functionality for fpm is something that I thought was a key feature that we needed at some point. So,
100% agree.
So being able to integrate something that somebody else wrote to actually implement that functionality without having to actually upstream it into fpm is incredibly powerful. So I love this idea.
And I think Git uses the same, or used to at least use exactly the same approach. Git.
Well, I believe Git is packaged almost exactly exclusively this way. The core Git executable doesn't actually contain any of its actual core functionality. It uses this this architecture where it just searches for a git dash whatever in your path.
Okay, so there is some prior art to show that, okay, this pattern is not awful.
Yeah, I thought you modeled it by Git. That's why. So it's an accident that you arrived at the same architecture, the dash.
Yeah, so I think Brad wrote that Git does it, but I didn't know that about Git.
Anyway, no, I think this is a good idea. The only thing is, in Git's case, I think they designed the whole Git, at least in the past, to be kind of independent, so that you don't have to need some functionality from a library. But in FPM, everything is kind of implemented in the FPM library / executable. So if you want to use any kind of functionality from it in your plugin, it's going to be tough. Unless you link against FPM. But at that point, you might as well integrate it into FPM itself.
Well, we could at some point migrate FPM towards Git's architecture and have FPM as a library and then have different projects that actually implement all the right functionality. So it's not outside the realm of possibility that we actually just move towards this as an architecture
That
altogether.
might be a good idea. And the other idea I have is, how do you install the search? Is it like FPM, you download the search and then you do FPM install in there?
So FPM search is completely third-party you know, it's an FPM package.
That's what I mean. So you use FPM to build it and install it.
Yes, but it doesn't have to be an FPM package. So when I do FPM search, FPM will just try to call fpm-search executable. So that executable could come from anywhere. It could be, how do you call it? It could be malevolent. But it just tries to find it on your system and it runs it. It doesn't have to be an FPM package. It just happens to be an FPM package here.
Yeah. No, what I meant is, if it's an FPM package, it's very easy to install as a user. It looks like
it is, yes.
You just do FPM install. Yeah, FPM install that
so
into your bin directory, and then it's available immediately. Or as long after FPM allows this architecture, it will be available. So from a user perspective, if they want to try, let's say we are prototyping some new feature, this is how to expose it to users very quickly.
Yeah, this is all I did. Copy pasted this.
Yeah. No, I think it's a great idea.
Maybe
Okay,
comment on the Git architecture. So none of the Git dash features is actually in the path. So those executables are found by a relative path to the main executable, I think. And there needs to be some configuration algorithm, some configuration file which creates those alias, which is read from the main Git executable and then points them to the Git subcommands, which lie in a separate directory. I think it's lib git or so, but it's nowhere near the actual path. You can't run git -new on your own on your system.
Sebastian, is the purpose of that to not pollute the user's path with all these git dash things?
That would be one reason.
Purpose, and I think the other purpose could be if you have something like FPM search, it doesn't need to know much about FPM, but if you have to have something like FPM dist, which should create maybe a source code distribution, then it has to know everything about the FPM model, and maybe this plugin wants to communicate that, what kind of information it gets from FPM.
Well, there are multiple reasons to do it this way, not least of which is security. You don't want to accidentally have some user put something malicious into their path, and then running a git command accidentally, does whatever that malicious thing was about to do. And you don't want them to just inadvertently break their git installation by putting something git dash something in their path, right? So that having some sort of a configuration file and not just blindly going out and searching the user's path is probably the safer route.
Basically, Brad, you're talking about alias git and git rm.
Mm-hmm. Yeah.
Okay, good feedback. So this PR has been open for a while. So please go there, comment on it, and let's see how it needs to be changed to make it work for us, specifically these issues that you raise with absolute paths, relative paths, and other things. Okay, I think this is all, Jeremy, for our agenda, right?
Yeah, I think so. There was no other.
Okay, we have 3 minutes left, and we have on the call here a few of the candidate students for GSOC. Specifically, Rachit asked to discuss a little bit about their potential project. So Rachit, do you want to say hi and say what you're interested in? They may not be on the call.
Rachit has left the call.
Yeah.
Okay.
Are there other students who would like to themselves?
I'm here, but I don't have anything much to discuss here. I was just listening to your stuff and trying to cope up with you.
Yeah, you could introduce yourself, or if not, it's not a problem.
No, I don't have anything up my mind to ask or discuss.
Cool. Yeah, thank you. If you want to discuss anything, you're welcome to post to the Fortran discourse. We can take it from there.
Yes. Oh, sure.
Chen, I believe you've been working on that linked list issue, right?
Yes, I've been working on that link list.
Okay, got it. Yeah, there's been quite a bit of feedback there already.
Huh.
Yeah, so that's an active thread.
But
Okay,
I'm
cool.
still
Uh-huh.
but I'm still stuck with finding some simple PRs that you advised me to find some simple issues to work on and put up some PRs over there. That's all.
Okay, I will look up a few and I'll post it in your discourse thread.
Okay, thank you.
As it is.
Huh.
Okay, unless there are other questions or comments.
May I have
you all.
like a really specific question about FPM, or is it better to ask on Discourse?
You have 1 minute. You have 1 minute left.
Yes.
Okay,
I'm
so
sticking.
in FPM, in SRC, FPM strings, is there a method which tests for like like the strings T that they are equal or not? Or how should I test for equalness of string T's?
Is the equals operator defined for that? I think it might be, but you might have to go.
I found only like contains, but like I could do it twice.
Yeah, from what I remember, I actually don't think we have implemented the equals operator for the string T type.
That might be a low hanging fruit there to
Yeah.
get that as a PR if you want.
We'll get it if we can finally depend on Stdlib and FPM.
That's right. Yeah. So we have to package Stdlib as FPM package, right? That should be.
Speaking of, Lawrence, is there any obstacle further for doing what you did with Stdlib FPM? Or is that just a matter of doing it?
Do you mean as in setting up the CI to do the pre-processing? Is that what you mean?
I guess, yeah, because FPM can pre-process.
Yeah, no, there's no reason why it can't be kind of upstreamed if that's what you want to do. I wasn't really sure whether that's what people wanted to do or not. But an idea is basically just to have it pushed to a orphanless tag, right? Or branch, I think.
Well, yeah. Well, we release it as a tarball. We'll include all the generated files in the tarball, and then FPM should work out of it.
Well, FPM can't work from tarballs just yet, I don't think.
We have to fix that.
Yeah.
Okay.
So if we could just push to a tag or a branch, then FPM can just.
Right. That's right.
Yeah.
For now. Yeah.
Yeah, I can open an issue on Stdlib, and it should be quite easy to do actually. Yeah.
Yeah, nice. Okay.
Great.
Well, thank you all for the to join the meeting. It was interesting, and yeah, we'll schedule. So yeah, next time I will propose the date. Do that a bit sooner, and close the date a bit sooner too. Okay. Thank you.
Excellent.
Thank you, everyone.
Good
Thank you.
discussion.
Bye.
Alrighty.